Hello students, welcome to classroom. I hope you are all doing well. In today's class, we will be discussing numerical problems. The numerical problem is from page 160, exercise question number 10. So let us solve the question together. So the question reads, an object 5 cm in length is held 25 cm away from a converging lens of focal length 10 cm. Draw the ray diagram and find the position, size and the nature of the image form. So this is a question on convex lens. Okay, so remember what I told you earlier, that every time you solve a numerical problem on lenses and mirrors, the first thing that you should do is to identify the type of lens if it is a question on lens, or the type of mirror if it is a question on mirror. So this is a question based on lens. So on reading the question, we come to identify that the lens is a converging lens. Which type of lens is called as a converging lens? It is a convex lens. So this question is based on convex lens. So very soon we'll be drawing the ray diagram also, because the question clearly specifies to draw the ray diagram. So we'll be drawing a ray diagram. Remember, the ray diagram will be about a convex lens. So we can just draw ourselves a convex lens here. Okay, this is the aperture, and since it is a lens, you will have to draw both the right side as well as the left side. Okay, so this is the right side, this is the left side. So extend the principal axis to both the left as well as the right side. Okay, so let us write down whatever things are given to us. So the first thing that we do is we start with the word given. So under this, we will be writing whatever things are mentioned in the question. On reading the question, an object 5 cm in length. So what is this 5 cm? This is the height of the object. So the height of the object has been given to us. So HO, height of the object, HO, is given to us. It's 5 centimeters. An object 5 cm in length is held 25 cm away from a converging lens. So this is the lens, and the object is placed 25 cm away from a converging lens. That means 25 cm is the object distance. So U is given to us. U is given to us. It is 25 centimeter. Remember class, that object distances, whether it is mirror or lenses, is always minus, negative. So universally it is negative. So do not forget to put minus. Okay, this is universal. Every time object distance will always be negative. Then the focal length is given to us from a converging lens of focal length 10 cm. So F is given to us. Focal length is given to us. Focus is given to us 10 centimeters. Now this is a question on lens. Now a lens has two focuses. One focus is on the left side. One focus is on the left side here. The other is on the right side. Okay, so the focus on the left side, this is the optical center. The focus on the left side, we have our F1 and we'll have our 2F1. Then we'll have F2 and 2F2. Okay, so the focus is given to us 10 cm. Now, which focus do we consider? Remember class, that the focus on the image side is considered. So if the image is formed here on the right side, then this focus will be taken. And suppose if the image is formed here, then this focus will be taken. Okay, so in which case the image will be formed, we will come to know later. So right now the focus is given to us. Okay, let us just keep it like that. What sign will it be? We'll decide on that. Okay, so let us focus now on the ray diagram. So since focus is given to us, let us mark the focus. So let me take this distance to be focused. So let me say this is F1. Okay, mark this side also another focus. Take the same distance, this much, and go here. So I get my F2 here. Remember class, the focus on the left is F1. The focus on the right side is F2. Now the same measurement, you take it and trace it back and mark it. This will become your 2F1. Taking the same measurement, you proceed again, mark it here. This becomes your 2F2. Okay, now let us erase this one. Now, if we read the question, focal length is 10. That means from here till here, okay, is 10. Similarly, from here till here is also 10. Okay, then this is f1. We know that 2f1 is double of f1. So from here till here is how much? 20. Similarly, from here till here is also 20. All right. Now, why are we writing these things? Because we have to know where the object is. If you read the question, the object distance has been mentioned. It is 25 centimeter. So the object is on the left side, okay, at a distance of 25 centimeter. So from the optical center till f is just 10 centimeter. From the optical center till f1 is 20 centimeter. The object is at 25 centimeter. That means the object is somewhere here. So the object is somewhere here. So it is beyond 2f1. Okay, beyond 2f1. So the object distance is, this is the object distance. So the object distance is given to us. The object is at a distance of 25 centimeter. Okay, which will be negative. Remember, the direction of light goes from left to right, from the object to the lens. Okay, this is the direction of light. All measurements starts from the optical center. So while measuring the object distance, we will be traveling in this direction, which is opposite to the direction of light. So it will be negative. Okay, measurements in this direction is along the direction of light. So measurements on the right side will be positive only. Okay, so the object is here beyond 2f1. So you can complete the ray diagram. If the object is kept beyond 2f1, if you remember the cases, then the image will be formed between f2 and 2f2. So you can just complete the ray diagram. Okay, then following rule 1, incident ray traveling parallel to the principal axis passes through focus. So let it pass through focus. The other one, we will use rule 3, which passes through the optical center. So following the rule 3, the ray will pass through optical center, and then we find the image to be formed here. Okay, between 2f2 and f2. So the image is here. Okay, so this is the second ray. This is the refracted ray. All right, so the image is formed here. Since they are asking for the ray diagram, we have the ray diagram ready now. So this will be the ray diagram. Yes. So focus, which focus should we be taking? We will be taking this focus. Okay, the focus from the image side. Remember, focus from the image side is always taken for lenses, whether it is convex lens or concave lens. So we will be taking f2. So f2 measurement, we will be taking this. The distance is 10 centimeter. So measurement will be done from optical center till f2. We are moving along the direction of light, so it will be positive 10. So this is plus 10. We don't need to write plus. Okay, so we don't need to write plus. If you want to write it, or else it's understood that it is always plus. Okay, plus we don't write. Now after that, draw the ray diagram. We have drawn the ray diagram, and find the position, size and nature of the image form. So we have to find the position of the image. Okay, so we have to find V, put a question mark. We have to find the size, question mark, as well as the nature. So nature also we have to find. So nature, question mark. So now let us continue with the solving. So we know, or we have, so we'll use lens formula, which is 1 by V minus 1 by U is equal to 1 by F. This is the lens formula. Put the values. 1 by V value we don't know, we are supposed to find V. Okay, minus 1 by U value is minus 25. Put it under bracket so that we don't get confused. Later on we will have to sort out the sign. Is equal to 1 by F. F is how much? 10 centimeter. In the next step, just sort out these two signs, minus and minus plus. So it will be 1 by V plus 1 by 25, and this is 1 by 10. Next step, 1 by 25 will be transported to the other side of the equality. So 1 by V, keep it here, equal to equal to 1 by 10 is here. This will go this side. We are bringing it this side, minus 1 by 25. Okay, so 25 comes here, becomes minus 1 by 25. What we do is we take LCM. 1 by V is equal to LCM of 10 and 25. Take the LCM of 10 and 25. 10 and 25. Though do not take shortcut. Always, okay, always follow the proper steps. So LCM, least common multiple. So 5, we start with 5. 5 2s are 10. 5 5s are 25. So 5 2s are 10. And then 10 5s are 50. So the LCM becomes 50. So LCM is 50. 10 5s are 50. 5 1s are 5. Minus 25 2s are 50. 2 1s are 2. Okay. So now we continue here. So what are we getting? 1 by V. 1 by V equal to 5 minus 2. How much is it? 5 minus 2 is 3. 3 by 50. So what we do now is we go for cross multiplication. Now in the exam, do not draw this cross. Okay, if at all you have to do it with pencil, and after that you erase it. Okay, so make sure that you have eraser with you and do this crossing with pencil if at all you have to do. I'm doing this to show you only. Okay, so it's V will multiply with 3. V multiplies with 3 and 1 into 50, which is 50 into 1, which will give you 50 only. So V is equal to 50 and 3 goes below 50. So V value will be found by dividing 50 and 3. So let's divide 50 and 3. So if we divide 50 and 3, 3 ones are 3. 5 minus 3 is 2. You get 20. 2 comes down. So 3 6 are 18. So 20 minus 18, you get 2. Point is there. Then you get 0 again. So 6 again, which will give you 18. Then again you get 2. Then 0 again. Again 6 again, you get 20. So we know what's gonna happen. It's gonna go like 6 6 6 like that. So the answer is 16.66. We can also write it as 16.7. Okay, we can just write it as 16.7. So this is the answer, 16.7 centimeter. Yes, centimeter. Okay, you may not write those centimeters, okay, while you are solving, but make sure that to write this, do not forget to write the centimeter at the end of the answer, or else you are losing mark. You'll be losing half mark just for not writing the unit. So it's very important to write the unit at least on the final answer. All right, so we are done with image distance, we are done with V. Now let's focus on the size. So let's find the size. So size. For the size, we have to use the formula for size, which is HI, height of the image, divided by height of the object, is equal to V by U. Now remember here, if this was mirror, if this was a question on mirror, the formula will be HI by HO equal to minus V by U. This is lens. In lens, the formula for size has no negative sign. Okay. Now another difference between the mirror formula and lens formula is, had it been a question on mirror, this formula will have positive sign. It will be 1 by V plus 1 by U equals to 1 by F. But this is lens, so there's a slight difference in the lens formula and mirror formula, and that is that the lens formula has negative, okay, whereas the mirror formula has positive sign. Remember that. Now HI value, that's what we are supposed to find. Size here refers to the size of the image. They want us to find out the size of the image. Okay, how big is the size of the image? So they want us to find the size of the image, which we don't have it. So just put HI here. We are to find HI, and HO is height of the object. The height of the object has been mentioned in the question, which is 5 centimeter. Don't write those centimeters now. V, we have just calculated V, which is 16.7. Okay, and object distance is mentioned minus 25. What do I do now? I go for cross multiplication. Okay, again, this X and all that, do it with pencil and erase it. Okay, so HI will multiply with minus 25, and we have 16.7 multiplying with 5. So we have to remove the decimal also. Okay, so first of all, let me just write HI is equal to 16.7 into 5, and minus 25 goes below that. Now let's continue the answer here. So now I'll remove the decimal. On removing the decimal from 16.7, the denominator, which is 25, will get 10. So it'll be HI is equal to 167. I have removed the decimal into 5. Below we had 25, and then for removing the decimal, because after the decimal there was only one number, which is 7. Okay, you get 10. 10 means 10, 20 means 100, 30 means 1000. Okay, remember that. So HI. So now let's simplify this in the lowest term. So 5 ones are 5 and 5 fives are 25. So you have 167 by, and 5 tens are 50. Denominator does not carry the sign, so let's give it to the numerator. HI is equal to divide 167 by 50. So 167 is divided by 50. So 50 ones are 50, 50 twos are 100, 50 threes are 150. So 3. Let us go with 3. 150. 167. So 167 minus 50. How much is it? This is 7 minus 0, giving us 7. 6 minus 5, 1. Okay. No more number to come. So put a point here and give 0. So still 50 threes are 150. And then 50, 60, 70, giving you 20. Okay. 0 minus 0, 0. 7 minus 5, 2. Point is already there, so you get 1 0 again. 50 threes are 150, 50 fours are 200. So 50 fours, 200. So finally HI is equal to minus 3.34. Okay, or HI is equal to, as per the textbook, minus 3.3 maybe. I think it's minus 3.3 centimeter. Okay, so this is the height of the image. The height of the image, look at the size of the object and the size of the image. Okay, visually also, okay, the object height is quite bigger compared to the size of the image. Okay, the image is much smaller than the object. So object height is 5 centimeter and the image height is 3.3. Okay, which is justified in the ray diagram also. Now what do we make of this minus? This minus indicates that the image is from below the principal axis. So this minus indicates that the image is from below the principal axis. Okay, above the principal axis you will get a positive value. So the height of the object is positive because it is above the principal axis. Below the principal axis, okay, the value will have minus. Okay, so minus because it is from below the principal axis. And finally, nature, we have to write the nature. So what is nature? This is real and inverted. So nature is real and inverted. All right, so this is question number 10 from the exercise. Okay, so with this I'll end the video, and then in the next video we'll be discussing another question, because in the textbook, the exercise portion, there are 2 questions. One has been done today, the other one I'll do it in the next video. So I'll see you again in the next video.